Hey guys, what's up? We are doing something very important today. We are going to be learning how to rate limit with Golang. We'll be learning 3 different approaches. So watch this video till the end, watch all the 3 approaches and pick the best one based on your preference. And so what is rate limiting? Rate limiting basically is when you have too many requests to your API server that might cause your API server to go down. So people who are trying to hack you might want to get your server to go down, so they'll send too many requests, or even somebody unknowingly might create an infinite loop and cause your server to crash by calling your API too many times. So this especially happens when you have public APIs. And I've shown you how to build API server in many different ways. You've done like more than 50 projects on this channel by now for Golang. You've built API servers using Fiber, using Gingonic, using so many different frameworks, right? But how do you handle too many requests? Now, this is a very, very important topic because when you go into production, when you're building a production grade application, you might actually definitely want to have a rate limiter, right? Now, this is what a rate limiter does. It receives all of these requests, but it prioritizes and sends only the amount of requests that the API server can handle. So it acts as a filter. So it can limit the rate per user. Sorry, or it can limit based on the number of times the API can be called. And this is basically protecting against denial of service attacks. That's what a rate limiter from a 10,000 feet perspective does. Now, like I said, we're looking at 3 different approaches. One is called the token bucket approach with Golang. So imagine this as a bucket, and when the bucket is full of all these requests and it's not able to handle any more requests, it starts dropping the request. So it's kind of aware about how many requests the API server can handle at any given point of time. So it takes in the requests up until it's full, and then it starts dropping these requests, and then the filtered requests go to the API server. For this, we're going to be using this package called x/time/rate. So you might want to check out the documentation of this package. And so this video is not a basic video in the sense I won't be covering the basics of Golang. You're expected to know that because we've covered, you've probably built a lot of projects already. This is when you already have a project and you want to think about rate limiting now, right? That's the right time to be watching this video. So the new limiter function is in this package, and this is the function that we'll be using actually. And it returns us a new limiter that allows events up to rate R. So we'll be sending it 2 values, R and B, which is the burst of at most B tokens. So those are 2 values we have to pass, and then we'll get our new rate limiter. So that's approach 1. The second approach is called the per client rate limiting. Okay, so we don't want to rate limit the entire application, which is what we were doing with the token bucket, because this will make it difficult for all the users to access our project. We don't want to do that. If only the problematic users need to be stopped, right? So I'm sorry, I think you were not able to see this text, so I'm just showing it again. So per client rate limiting basically is that you don't want to rate limit the entire application, because that will make it difficult to access for all users. It's only the problematic users need to be kept out. Hence, we rate limit based on the client. So these are the clients. By client, I've just shown you like a person who's a client, but the client is actually just a browser, right? Or somebody who's trying to call your API. It could be another server that's trying to call your API. So we'll check the IP address when rate limiting the requests. So this is the different approach that we'll be following. The second approach. The third approach with Golang is that we'll be using this package called Toolbooth, and this is a scalable library. It's an already existing library, quite famous, and it implements multiple types of rate limiting behind the scenes. So we don't have to write any of our logic on our own. So this will implement leaky bucket, time-based limiting, all of that on its own. So I'll show you also how to use this library as well. So we'll cover all these 3 approaches. Now, before we start coding, before we get started, whenever you have any problems with any of the videos on my channel, make sure you join this community, which is the Akil Sharma YouTube community on Discord. The link will be there on my YouTube, and we talk about a lot of stuff like how to make any particular code work, or how to get a remote job, how to get jobs, internships, blah, blah, blah. So there's a whole community of a lot of people to help you out. And the other thing I want to tell you about is the 6 AI plus Go advanced project that I've released just some time back. So I will put the code for 50% discount for you guys. So I had kept it only for the first 50 people, but that's already sold out. But I'm still extending it for a while because I want the YouTube followers at least to benefit from this. So I'll put the coupon code there. If you're looking for a job in 2024, want to stay relevant, you might want to check out this course, because AI is what people are looking for in a resume, right? AI, ability to work with AI basically. So with AI and golang projects, we'll build 6 advanced projects, production level, 26 hours of content, a lot of value for you guys, building a Discord bot, Whisper API bot, Telegram bot, Kubernetes AI Assistant, Terraform AI Copilot, and Terminal AI Assistant. Right, so check it out if you get time. And the last thing is that this particular video that we are looking at today is going to be part of this 52 killer Golang projects, but this will actually become 53 because we'll add today's video, and it'll be somewhere in the middle that I'll add it. So make sure you do as many projects from here as possible and share this with your friends. It's the free resource, and it's a free resource, and it's the biggest collection of Golang projects anywhere on the internet. You know that obviously by now, so make sure you share it with your friends so that everybody can benefit from it. Anyways, I've talked a lot. Now let's start the project. All right, so let's get started. I'll just make a directory for go rate limit YouTube, and I will cd into it, and I'll open this up with the VS Code. So here we'll have 3 total folders, as you know. One would be the toll booth, which we'll cover at the end. Then we have the bucket, so the token bucket. And then we have the per client rate limiting. All right. So each of these projects, we will create a mod file for each of these projects. So what I'll do is I will seed into each of these. So I'll say per, and here I'll say go mod init github.com /Sharma90 /per client rate limited. Okay, and then I'll cd into the token bucket 1, and I'll say the same thing, but here I'll just change it to token bucket, and I will then go into the toll booth, and here we'll just say, okay. So we have 3 mod files now. All of them have a mod file, and what we're going to start with is the token bucket. So here in the token bucket, I'll have 2 files. I'll have the main.go file, and I'll have the limit.go. So in the main.go file, what I'm going to do is I'm going to say package main, and I'll be importing a few packages here, obviously, and then I'm going to define a message struct. This will have my status, and the body, and you'll soon see why we are using it, so don't worry, don't panic. You'll soon see why we need the message, because when somebody hits our API, I want to send them a message, right? And then we'll have a endpoint handler. Basically, what will happen when somebody hits our API? So we'll just have a very simple API, like a ping API. Somebody calls it too many times, we want something to happen, right? And when somebody hits the API once, we'll show a message. But if they try to call it too many times, we'll have a rate limiter that you have to go and you have to get through before you can go hit the endpoint handler. So here you have your writer, which is of type http.responseWriter, and your request. So you have your request and response objects, quite straightforward. and let's set what we want to send back as response. So first we'll set the content type, which is application/JSON, and when somebody hits this API, I want to say I want to return 200, which is the status code, which is status OK. And then I want to send the message. So that's why I created the message struct up there. The message will have two fields, as you can see here, status and body. So in the status, I'm going to say successful. And in the body, I'm going to say, hi, you reached the API. How may I help you? So just to tell the user that he has successfully reached the API, and we will use the regular JSON package and encode our message into JSON. And while doing that, if we encountered an error, we will handle it as well. So we have our little handler, which is supposed to be called. This function is supposed to be called whenever somebody hits our API, right? Everything is straightforward up until now. Now we have our main function where this API is actually going to get called. So we'll have http.handle. So as you can see, I'm not using any framework here, just good old HTTP. And here I'm actually going to first just call the endpoint handler. That's it. And I have to run this on port 8080. And if there is an error while running this server, I want to print out there was an error listening on port 8080. Okay. And yeah, so I used the JSON package, so I'm not sure why it wasn't imported here. I want the encoding /JSON also. Okay, so we have our main function, and whenever somebody hits our API, which is /HTTP on port on localhost 8080, we're going to send it to our endpoint handler, and this is going to return successful. Hi, you've reached the API limit. How may I help you? But we don't want the API to be called too many times. So what do? We actually create a rate limiter. So we'll create a rate limiter, and to our rate limiter is where we'll pass this function endpoint handler, and the rate limiter we are going to create here in limit.go. So limit.go is again package main import. I'll import a couple of packages, and you know that I'm going to be using external package, which I've talked about earlier, which is x/time/rate, and you have the rate limiter function. So here I'm going to accept something called as next. So if you see here, I'm passing this function called endpoint handler, and here I'm accepting it as next because I want the rate limiter function to be called, and automatically if the rate limiter allows it, then I want my endpoint handler function to be called. So that's the next function in the line of functions to be called. So rate limiter automatically will pass on the baton to the next function. Okay, the next function being the endpoint handler function. So here I'm going to say this function, which I'm going to be accepting in this function as argument, is going to have a response writer and request. and returns a HTTP handler. Now is when we'll create our rate limiter. So our rate limiter is equal to rate, the rate package that we have here. And we'll have to run go mod tidy, by the way, to get this package after we are done with the coding. And I'm going to pass 2, 4 here for the two values R and B. So we have our rate limiter now. And at the end, I'm going to say next W, R. So I'm going to take my response writer and my request, and I'm going to call the next, going to pass on the baton or the function control to the next function, which is the endpoint handler function. But before that, I want to do a check. I want to do a check of, let's say, has this API been called too many times? So that check will be done here. So for here, I'll have a handler func of its own, which will have http dot response writer, R, which is http dot request, and inside that we are checking if the limiter that we have created here is not allowing any more requests. That means the requests we have called the API too many times, and if that is the case, we want to send, based on the struct that we have, the message struct, we're going to send a status which will be request failed, body is the API is at capacity, try again later. Okay. And we're going to send back a status code for too many requests. Too many requests. JSON dot no encoder. And here we'll put an else, and that we'll put the next method. Right. So what's happening here is we're checking if the limiter, if the API has been called too many times. So limiter does not allow. If it doesn't allow, we'll say the API has reached its capacity. If it's not reached its capacity, then we're just going to call the next function. The next function in this is the endpoint handler. So we're only getting till endpoint handler only if the rate limiter allows that. Otherwise, we won't get there. So that's the token bucket. And what we'll do is we'll run the token bucket. We'll understand how it works, and only then we'll go forward. Okay. So what we'll do here is we will go into token bucket, and we will run go mod tidy because we still have to get that rate package. Now we have that, and now we'll run this program. Okay, so what you're going to do is we're going to run the program and see if we have any issues. So as expected, we have some errors. And what I want to show you here is that with Golang, I'm sure you've been doing all these projects with me, but I'm sure I just want to also remind you again that Golang is an amazing language, Golang and Rust both. And you can be completely drunk when you're writing code, and you can make all the mistakes you want, but the compiler will exactly tell you what the issues are and what those issues are. So you don't have to be really smart to write Golang code. Okay. And the problem is on line 17. Yeah, I can see the problem. And mostly the other issue is because of the previous problem, and which I'm correct. On line 19, there's some issue on line 19 of main.go. Okay. Yeah. There's no comma. Is that it? I think that is it, maybe. So Status OK is not defined on line 16. Okay. Status OK. Yeah, because the K needs to be capital. Status OK. All right. Now, hopefully it should work. Yeah, so now the server is running. I've kept it really simple. There's no elegant message of, hey, the server is running and all that. So what we'll do now is we will open up another terminal. And I'll just make this smaller. And here is where we will run the API once. We'll call the API once. Let's see what happens. So I'm getting HTTP OK, which 200, which is OK, which is everything is fine. You have reached the API. How may I help you? Right? Everything is fine. But what if we try to call it too many times? So I don't want to like manually call it too many times. So I've written like a small for loop. I'm gonna call it a few times. And after 4 times, we see that the request failed. Yeah. So we allow only 4 times for it to be called, and it says after that the API is at capacity. Run it again. Again, you get 4 times you're allowed to call it, and then after that the API is at capacity. Try again later. So you have to wait for a while before you can call the API again. Okay, so this is how the token bucket works. So it's working perfectly fine now. And what we will now do is we will start with the next one, which is per client rate limiting. I'll stop the server and cd into per client, and I will open up the code here and close this off. And for the per client, what we're going to do is we're going to have a main.go file here. So there's not a lot of change from token bucket, okay, because we're going to be using the same x/time/rate package, same one. We're going to have the same message struct, right? So not much has changed, but a few things will change, and I'll tell you exactly what. As in, you'll have to obviously check for the IP, right? The client IP. So let's do that. Okay, so let's start with saying package main. I don't know why that came here. And then we're going to import a couple of packages, of course. And we start with a message struct. Message struct, again, like last time, has a status, has a body. This is string. JSON. Okay. This again is string and body. So we have we're going to have our main function, of course. We're going to have the endpoint handler, just like last time, which is the function that handles the API call. Whenever the API is called, this is where we want the user to go, but he can only go here if our rate limiter allows, right? Just like last time. So we have our endpoint handler with takes in writer and request, HTTP response writer and request, and we write the same stuff. So what I can do is I can just copy and paste everything here just to save time, right? So we have our header, setting our header, writing the header with status OK, and we have our message, successful, how you reached the API, how may I help you, and you have your encoder, and if there's an error here while encoding our message, we're going to return from the function. Then out here we have HTTP.handle /ping per client rate limiter, and here we'll send our endpoint handler. So Very similar, we have our endpoint handler, but obviously we don't want it to be called directly. We want to first call the per client rate limiter that we'll have as a function here. The per client rate limiter. And that returns the HTTP handler. So the setup here is going to be the same. This is going to accept a function called next, and that function again has writer, which is of type http.response writer, and request, which is of type http.request, right? Very similar. And from this function also at the very end, you are returning, you're calling the very next function. So if everything goes well, right, and the client has not called the API too many times till now, then we would want to call this next function, which is the endpoint handler. And we'll continue working on our per client rate limiter, but I need to start the server. So I'll say http.listen and serve. And handle the error here. So if error is not equal to nil, log.println, there was an error listening on port 8080. Okay, so coming back to our per client rate limiter, here I'm going to say return http.handler func, takes in a function response writer, request. And the first thing we want to do is we want to use the net package to get the IP address from where the request is being made. Okay, you remember per client rate limiter is all to do with the IP address of the client. So if we have the IP address, we know how many times that particular IP address is calling the API, and you want to limit that particular IP address and not all the other IP addresses. Okay, and this is why this is a more efficient or effective rate limiter. So we don't end up rate limiting the entire application, just that particular IP address. So we got the IP address, and we'll handle the error that we might face while getting that IP address. So write header status internal server error, return. Then before I write the rest of the code, I actually want to create a few things here on top. So one is a struct called client. So in this struct we have something called as the limiter, which is going to be rate.limiter, where rate is the package that we had imported earlier, which is an external package available to us as in x/time/rate. And then we have last seen time.time. So limiter helps us define how many times the particular IP address will be able to call, and that will be defined with our client. So client and IP addresses will be associated, and we'll be able to define for that client how many times he can call the API, and we'll have the last seen field, which is when was the last time he had called the API. So that's why we're keeping the last seen as a field, and it's available to us in our time package. So if I save, hopefully I'll get the time package. Yeah, I was able to get it. And then I will create two variables. One is my mu, which is sync.mutex, which I'm going to be using now, and then my client's map. So I'll make a new map, a collection of my clients. So I have the client stack defined here. I want to make a collection of those clients. Okay. And now yeah, so we'll come back here now. Okay. And we have our client's object and client's collection, and with the help of the IP we are able to access each of the clients. So clients and each client and IP address are associated, and when we have the IP of the client, we'll be able to access that particular client, and we are checking if that particular IP is found in our client's collection. If it's not found, then clients the client with that IP address will set the limiter value for that. Okay, so let me explain again if you have not understood. What's happening here is we have a client struct, and that we are defining how many times he's going to be calling the API, and then we have a last seen field, a limiter field, and a last seen field. The last seen field will basically have the timestamp of when he called the API last. Now we're creating a client's collection, which is a map of multiple clients, associating IP addresses with the client, with each client, and creating a collection. The reason we have this collection of clients is because we want to know, we want to keep the list of all the clients that are currently calling this API. So we're going to have this in our clients collection. So if that particular IP address is not found in our clients collection, that means he's calling our API for the first time, right? He's never called the API before. If he's never called the API before, you want to initialize that client, you want to create a new instance of the client, and you want to set the value of his rate limiter, because that currently doesn't exist, right? So anytime a new client calls the API for the first time, never called it before, you're going to set the rate limit value for it. And regardless of the client, and obviously if the client exists or doesn't exist, because if he was not found, we've already added his rate limiter. And now for the clients that exist, now what we want to do is we want to update the last seen field, right? So if the client was not found, we initialized it, and we initialized the limiter field. And now we are checking this for all clients. For all the clients that are calling this function right now, we are updating their last seen, just so that we are aware of when they call the API last. And here the same, we're going to do the same thing. Clients IP dot limiter dot allow, right? So not allowing, the limiter is not allowing, right? Just like we did last time, which is if the limiter was not allowing, then we were saying the API is at full capacity, blah, 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 blah. And here I'm just going to use the mutex that I created. So I'm going to say mutex.lock and mutex.unlock. And I'm going to send the message, which is exactly the same message as before. So I'm going to go ahead and actually copy paste this whole thing. Copy paste this whole thing here. Sorry, the mutex.unlock also got deleted by mistake, so I'll just add it back. Okay. And finally, after that, we'll have mu.unlock and add the next function here. Okay, so we'll execute the next function. All right. Now there is one thing missing. The one thing that's missing is when do we actually remove these clients from our client collection? Because we know when we are adding them, which is when they call our API for the first time, but we also want to be removing these clients from our client collection. So here we'll create a routine, and we'll say for time dot sleep, time dot minute, and dot log, and we're going to say we're going to range over all the clients, access their IP and the client, because those are the two fields in the client's map. And we're going to say if the last seen of the client is greater than 3 minutes, then we can delete the clients. Delete that client. And here let's say new dot unlock, and we'll have to call this function. Okay, so we're maintaining all the clients who are calling our API in the clients collection, which is a map, but we don't and if they try to call the API too many times in 3 minutes time limit, then we stop them. We say, hey, the API is at capacity for you specifically because of your IP address. But if it's more than 3 minutes, then we'll just remove the client from the client's collection. We'll remove that IP address from the client's collection. Okay, so that's what we're doing. I hope you've understood the whole thing, but what I can do is I can explain everything to you very quickly here. Again, this whole function, the per client rate limiter, created a client struct with limiter and last seen, limiter for how many times the particular API can call, and last seen is we're updating that every single time the API is called by that IP address. Two variables, mutex and clients, and clients is the collection of all the clients, and we have this logic to delete the client from the client's collection if the client was last seen more than 3 minutes back. Okay, because now if he calls the API again, he'll be treated like a new user who's calling the API for the first time, and we are checking the client's collection for that IP address. If he's not found, that means he's either calling for the first time or he's calling after 3 minutes and he doesn't exist in the client's collection. So we'll create, we'll add that IP address to the clients, and we'll create a new client with limiter, setting the limiter with new rate limiter. And yeah, and then we'll have our last seen, and then we are updating our last seen every single time this API is called, and then we are also sending this message if the client's IP address for that particular IP address the limiter has exceeded, we'll say the API is at capacity, and that's it. That's how the function is supposed to work. Now what we'll do is we will run go mod tidy here. So we'll run go mod tidy, and we're going to go ahead and run main.go, and oh, it's working. There's no errors. Awesome. So we will create a new terminal like we did earlier. So let's go ahead and create that. Create a new terminal, and again I will write the for loop to call this API multiple times, and it was successful for the first 4 minutes, then the request failed. Okay, similarly successful and the request failed. So that's how this is working out. So this project is also working, so our per client rate limiter. And now I have to show you the last one, which is the toll booth. So we'll go into the toll booth, and I will open that up here, close everything else, open up toll booth. The toll booth also has a main.go file. So I'll go ahead and create the main.go file. Now the toll booth one is actually the simplest. So again, it has package main, going to import a few packages, and the most important one here will be the toll booth package, which is an external package we're using. As you know, toll booth helps us do everything and abstracts away the logic for us. It handles everything in the background. And here we have the exact same message and exact same endpoint handler that we have been creating in the previous two functions. And here we have our main function, which has the message for the API hitting the limit. And we are also going to marshal this message that we just created. And we're going to create a new toll booth limiter, which is equal to toll booth package dot new limiter and 1 comma nil. And we're gonna set, so we're gonna say toll booth limiter dot set message content type application slash JSON, and we'll also set the message, so we'll say toll booth limiter dot set message and string, and then the JSON message that we have from before, this one. And now we're gonna use our HTTP package with the handle method, define our API, which is ping, and when somebody hits the ping API, we are going to call the tollbooth.limit func handler. So all the logic is happening here in this package, in this function, the tollbooth func handler, and we are going to pass in the tollbooth limiter that we created and the endpoint handler function that we have above. And we're going to start off our server. So listen and serve on port 8080. Nil, and we'll check for the error here. So if error is not equal to nil, we'll log dot println there was an error listening on port 8080, error. Okay, so that's our entire function, entire file. So here what you're going to have to do is you will go ahead and run go mod tidy. So all matched no packages. What does that mean? Okay, I think somewhere I've made some mistakes, so let me check it out. Okay, so I've realized the issue is that the main file is not there in the tollbooth folder in the first place. So we'll have to do that, and then we'll run go mod tidy, and it should find the tollbooth package, and we should then run. So here it's saying limit func handler, because you can see the spelling is wrong, 38, line 38, and blur is not defined. I'll quickly again explain the this tollbooth to you. You have the message, you already know about the message struct, you already know about the endpoint handler. We've done it in the past two examples also. Here all we're doing is creating a message that we've always created where the API is at full capacity, and we have marshaled the message. These three lines are new, which is we're creating a new limiter using the tollbooth package, setting the content type for application JSON. We did that previously as well, and we've set the message that we'll be sending from the rate limiter, and which is this one. And then we call the tollbooth.limit func handler function, which takes in the rate limiter and the endpoint handler that we want to call if everything goes well and the rate limit has not been exceeded. Start the server, and that's it. That's about it. So here what you want to do is go run main.go. Okay, and what you want to do now is you want to call this API. Sorry, not from here, from a different terminal. You want to call the API. Quickly call it from here, and again we'll get a different type of message. It's all JSON, and here we'll say request failed. The API is at capacity because before that we got successful. You've reached the API. How may I help you? And then you got request failed. Then again you got API is at capacity, which is request failed basically. Okay, so that's the rate limiter called tollbooth. So everything works perfectly fine. Hope you learned quite a lot in this video, and don't forget to check out the other projects in those 53 Golang projects list. Don't forget to check out the AI Golang project course that I've created, the 6 projects, 26 hours of pure learning, creating production level applications. Thank you so much for watching, guys. I'll see you in the next video.